Hello everybody, this is Sujit here once again from Longman Energy. Now Longman was founded more than 8 years back in order to innovate and deploy renewable energy solutions, especially in the field of distributed solar. In order to make ourselves future ready, we are also working on energy storage solutions as well as deploying some very critical technologies such as artificial intelligence, machine learning, and the most important of it all, blockchain technology. Now, in my previous video, I discussed the very basic of energy storage. And in this video, I shall be discussing the very basic of blockchains and blockchain technology. In subsequent videos, I shall also be discussing the limitations, the challenges, as well as amazing potential of this technology. Now, blockchains are not something which is only going to change the renewable industry. It is also going to change each and every aspect of all our lives. And when I say all our lives, I mean each and every person on this planet, be it somebody working in high finance in New York, or be it somebody who is unbanked and living in sub-Saharan Africa. So let's move on and find out what is a blockchain. And before we plunge into the blockchain story, a quick look at Longman Energy, the amazing company that we built more than 8 years back to counter climate change. Now we got to realize that the disasters that could be unleashed by climate change are going to be way more consequential than those brought about by the pandemic that's raging across the world as this video is being recorded. So we all need to make a concerted effort to counter climate change. And we at Longman believe that the blockchain powered technologies will play a big role in decarbonizing the generation, transmission, and distribution of both energy and electricity. So let's go ahead and see what a blockchain is in the first place. So there are blocks and there are chains, and together they add up to make a blockchain. Needless to say, the block that we are talking here is a digital block that can hold information. The digital chains linking these blocks safeguard the data in the blocks in the most secure and non-temporal manner known to mankind till date, and thus making the blockchain decentralized, trustless, immutable, distributed, and append-only. We'll see as we move along in this video as to how these properties of blockchain are realized. We'll start this discussion with blocks. A block can hold information related to transactions. Now these could be monetary transactions. For example, let's say Goofy transferred 10,000 bitcoins to Donald. That's a monetary transaction. On the other hand, it could also be a business transaction. For example, Enron's contract with Lehman for capital raise. Or for that matter, an accounting information such as Facebook filing its quarterly financial statements. Now, what information a block can store in it is decided by the developers or the users of the blockchain. For example, Bitcoin blockchain can hold only information about monetary transactions, whereas Ethereum blockchain can hold information pertaining to both monetary as well as business transactions. Meanwhile, Hyperledger from Linux can store only business transactional information. Now, every block in a blockchain is supposed to have a predetermined information carrying capacity, and this limit is called block size. And block size once again depends on which blockchain we are talking about. In Bitcoin blockchain, every block can store up to 1 MB of data. Meanwhile, one of Bitcoin forks, that is Bitcoin Cash, has a block size of 8 MB. In Ethereum blockchain, the block size is determined by the gas limit. We'll delve deeper into this in a separate video to learn more about gas limits. Meanwhile, Hyperledger holds transactions collected within 1 second, but with a maximum limit of 5,000 transactions. Conclusively, we have learned that every block has to have a predetermined size as well as information type that it can store. Now, how is the information that we store in a block safe and secure? For all we know, there could be an international criminal, let's say by the name of Boris, who would hack into the file containing information pertaining to Goofy's 10,000 bitcoins and change the ledger name to Boris so that when it's time to return the money, Donald may accidentally or inadvertently pay the money back to Boris instead of Goofy. This safety and security of the information in a block is provided by the chain in the blockchain. However, in order to understand chain, we need to have an understanding of the blockchain platform first. Now, a blockchain is a peer-to-peer network wherein the users of the blockchain are all interconnected. There is no central authority which is controlling this interconnected platform. In fact, the platform is run and managed by the users of the blockchain themselves. So, how is a blockchain managed? Some of the users on the blockchain volunteer as nodes. These nodes carry a copy of the entire blockchain on their computers. Also, they dedicate their computational capacity to power the blockchain. This could mean lending some computational capacity of their laptop or even setting up large dedicated computer farms. Now, all the transactions which are to be recorded in the blockchain are transmitted to all the nodes simultaneously. The nodes then validate and verify each of these transactions. At a point in time when the total size of the information received matches the size of the next block to be created, the blockchain randomly picks a node for block creation. You will see later on that this randomness is going to have a huge role to play in keeping the information in a blockchain safe and secure. Now, this randomly selected node, like all other nodes, has already validated and verified all the transactions that is to be included in this block. On being randomly selected, what this node does is it takes three sets of information. That is, all the information pertaining to the transactions that are to be included in this block, the time at which this block is to be created, and the previous block's hash. A hash can be thought of as a unique label that every block of a blockchain has. So it takes these three sets of information and puts it into something called SHA-256 and gets the hash or the unique label for this new block to be created. Now, the blockchain logic is so designed that as soon as hash 2, that is hash of this new block, is derived, the new block gets created. But apart from the new block, what has also been created is the chain. That is the link between the newly created block and the previous block. Now, we say this because you must have noticed that the hash of the new block is a function of the previous block's hash. And this stays true for each and every block on the blockchain. And it is this link or chain that is going to safeguard Goofy's 10,000 bitcoins from Boris, who is still thinking and dreaming of them. Now, I don't wish to keep you wondering as to what SHA-256 or a hash is. So before we move further, let's have a very quick look at these. SHA in SHA-256 stands for Secure Hash Algorithm. It's a cryptographic hash algorithm developed by the NSA, that is National Security Agency of the United States. What it does is, no matter what you give it on the input side, you will always get a 256-bit output. This input could be your name, it could be the details of all the Batman images ever created, or it could be the entire Harry Potter series. No matter how small or large, how simple or complex, piece of information that you're inputting into SHA-256, it will always give you a 256-bit output. Now, if you're wondering what a 256-bit output is, here are a few examples. Now, these are not just any random 256-bit numbers. They are in fact the hashes of block number 4510, 690, 691 and 692 of the Bitcoin blockchain. I promise to delve deeper into this in a video dedicated to hashing and encryption. But for now, let's get back to our blockchain story. Getting back to the blockchain story, we see that this randomly selected node has built a new block, and in the process has also created a chain, a link to the previous block. Now, why do these nodes volunteer with their computational capacity and build these blocks and maintain the blockchain? Well, the answer is they do it for block rewards. How much block rewards you get depends on what blockchain we are talking about. For example, in the Bitcoin blockchain, currently you get 6.25 Bitcoins for every new block. And at the time of the making of this video, that's worth $240,000. In Ethereum blockchain, as of today, you get 3 ethers for every new block. and that's currently worth $7,900. Meanwhile, in the EOS blockchain, there is a complex math there. You get 1% of the inflation adjusted production, and thus the dollar value of these varies. Now, these reward values are only true for the time this video is being recorded and keep changing. Rather, in most cases, will keep going down as the blockchains expand. Meanwhile, the nodes stay interested as the dollar value of these rewards issued in the form of cryptocurrencies mostly keep rising in the long term as blockchain networks expand and become more popular. However, in the short term, probably you already know this, that the dollar value of the Bitcoin and the Ether and other cryptocurrencies are in fact one of the most volatile numbers that you could ever look at as far as price charts go. Now the big question is, with all these rewards and effort, is the blockchain really made safe and secure? To know that, we need to call back on Boris. Now let's say some time has passed and more blocks have been formed after a block with hash 2. But Boris has not forgotten those 10,000 bitcoins of Goofy. He's been lurking around, and at the first wind of opportunity, he swoops in and hacks into the block which has the transaction information pertaining to Goofy's bitcoins. But as soon as he changes Goofy's name with his own on the file, the hash of the block changes. Simply because the block's hash is a function of the transaction information inside the block. Also, as the hash of this block changes, the hash of the next block also changes, as the hash of every block is also a function of the previous block's hash. And as hash 3 changes to hash y, it also leads to the change of hash 4 to hash z, and so on and so forth. And before you know, all the block hashes after the block which Boris hacked into, including this very block, changes once and for all. Now at the network level, all these block hash changes are only going to be witnessed at the node where Boris carried out his attack. Meanwhile, the copies of the blockchain located at all other nodes would continue to record the same sequence of hashes as before. Now the network will immediately realize this inconsistency, and the entire copy of the blockchain at the node where the hack was executed is going to be discarded by the blockchain in no time. Not only that, the node at which the hacking was executed will get immediately replenished with a non-tampered copy of the blockchain, making Boris realize that all his efforts just went down the drain in less than a minute. Now Boris is really angry, as he's just realized that it's not enough to hack just one node of the blockchain in order to carry out a fraud on the blockchain, and that he would in fact need to hack into every node simultaneously to commit a fraud. Now that's a big task, considering, for example, in a Bitcoin blockchain there are like 200,000 nodes. Thus, even for an international criminal such as Boris, what's going to be difficult is to hack into all 200,000 computers spread across different parts of the world at a single given point in time in order to commit a fraud. What's going to make Boris's life really difficult is the fact that these 200,000 nodes are not even fixed. They keep coming in and going out of the network all the time. This means Boris will have a real tough time just locating those 300,000 nodes that are going to be active at the exact time that he plans to commit the fraud. Now, some of you may ask, what if Boris himself becomes a node in the blockchain? Would he not be able to be one of the validators and verifiers of the blockchain and sneak in a fraud transaction for future record? Well, that's where the randomness of the blockchain comes in. Because if Boris wants to steal Goofy's bitcoins, he will need to position himself as the node exactly at the time when the block with information pertaining to Goofy's 10,000 bitcoins is about to be created. But as we had previously seen, the selection of a node to create a block is truly random, which means Boris's chance of getting picked up for recording a specific event on the blockchain would be extremely thin at 1 in 200,000. And quite frankly, the chances of Boris being hit by a comet while he's planning his attack on the blockchain is higher than he actually being able to hack into the blockchain. Now, a small word of caution as we near the end. What you just heard from me was a short and oversimplified explanation of a blockchain and its workings. Some of the details that I just shared may not only need to be elaborated but even altered somewhat as we explore this ecosystem of the future further. Now, having realized how safe and secure blockchains are, especially with no central authority to maintain or manage them, we are sold on the idea and are building on the blockchain technology as we plan the future of energy. So, join us in our journey as we plan to release a total of 45 videos explaining this amazing futuristic technology that we ourselves are building upon. So join us, follow us, and subscribe to our channel to know more about blockchains as well as various other technologies that we at Longman are currently working on.